If you are interested to know more about the Six Sigma and how it can be applied to improve your business in terms of operational and financial KPIs, follow us with our Six Sigma sessions in where we will explain different simple techniques, how you can better control your business, and how you can generate more savings and more profit. My name is Haitham Layadi, a Lean Six Sigma consultant with Sigma Plus Industrial Solutions. Don't go away.
So, hello, friends, and once again, we continue our discussion about the Six Sigma. The Six Sigma is actually a statistical tool which is used to improve the quality. It reflects the voice of the customers in our processes to improve the level of the satisfaction. It has two major targets. The first one is to reduce the defects and the variations existing in the processes. And the second goal is to reflect the voice of the customer into our processes. So, in other way, we can say that the Six Sigma is a quality improvement methodology that relies upon statistical tools to remove the defects and remove or reducing the defects and the variations which are existing in our processes to achieve the highest level of the customer satisfaction. And indeed, if we reach to that level, we should have a strong reflections on the business operational and financial KPIs. So we've been speaking about the Six Sigma. So what is the Sigma level? The Sigma level is a statistical measurement. It measures statistically the quality efficiency. So it's scaled from 1 up to 6 or from 0 to 6. And as highest is the level of the Six Sigma, as the highest is the customer satisfaction with the lowest rate of cost of quality. In case the Sigma level is in the lowest as 1 as an example, we should have a cost of poor quality more than 40% out of the annual sales. I want to correct myself, cost of quality and not the cost of poor quality only, because the cost of quality is covering the cost of poor quality plus the cost of all the correction and corrective actions that we are taking to improve the quality in the organization. So you can see even the customer satisfaction will be the lowest as it is in case that the Sigma level is down. There is a classification for the Sigma level based on the competition, the worldwide competition, and those companies who are having a Sigma score between the 1 and 2, they are classified to be a non-competitive, while those who are rated with 3 and 4, they are in the average rate, and those who are in between the 5 to the 6, they are known to be the world class or the best in class. And as you can see that the cost of quality for the world class should be less than 10%. So let me give you an example. If I have a company having a Sigma score of 1, that means that the cost of the quality should be around the 40%. Um, if the annual sales is $10 million and the Sigma score is 1, that means that the cost of the quality existing in that organization should be around the $4 million. And indeed, you will see that all the KPIs will be in the red zone due to the problems existing in the execution or in the planning, in the projects, and so on. So the main scope of the Six Sigma is to improve the quality by reducing the defects and the variations existing in the processes. There are some basic Six Sigma metrics that we need to understand. The first one is the defect, and the defect is known to be any kind of failure existing in the product. And a defect is known to be a non-conformance to the customer requirement. A requirement means the requirement of the customers. And the customers, as you know, they are classified internal and external customers. An internal customer, as an example, is suppose that you are, for example, an accountant, and you are reporting all the operation expenses of the company, and you are reporting to your boss, to your manager. So the manager is your internal customer. An external customer is a customer that the company is dealing with him and delivering final services or finished products. So a defect is a non-conformance to the requirement. Your manager, he needs from you a complete report about the operation expenses with no mistakes in calculations and so on. So that's a customer requirement. The external customer requirement, he would require to get his services on time without any delays, without any problems, without any reworks or modifications or after sales call and so on. A defective is a complete failure for the product. A product might contain a defect, but a defective product is a complete failure. The defects per unit, or the DPU. The DPU is the actual defects that happened during the month, and they are divided by the number of the units produced. So as an example, if I say that we have reported 300 actual defects and we have produced around 100 units. So if I divide the 300 by the 100, that means that I have 3 defects per each unit produced. Then I have what it's known to be the DPM, or the defects per million opportunities. And this parameter is mainly used to understand the average rate of the defects existing in the organization, as we will see later on in the formula of calculating the sigma level, how it's important to know the DPMO. So the DPMO is calculated as per the shown formula, the number of the defects divided by the number of units produced, multiplied with the number of defects opportunity per unit. So let me explain to you that formula. The number of defects are the actual defects that occurred in a specific period, the number of units produced. The number of defects opportunity per unit is your estimation for the possible defects that might happen in a product. We will go in further detail through the DPMO in a work example. Then we have number 5, the parts per million defective, or what is known to be the PPM. And the PPM is the number of defective unit in 1 million unit. So it's giving just an average rate for the defective. So the first one was related with the average rate of the defect per million opportunities, and the second one is the average rate of the defective, the PPM. And this is the formula. It's calculated by dividing the total number of defective units in a sample. It means if I consider that I produced 100 units this month and I found 2 units damaged, that means that my percentage of defective was found to be 2%. And by multiplying that percentage of defective with the 1 million, I get what we call the parts per million defective, or the ppm. Another two parameters are so important to know is the TPY and the rolled throughput yield, the RTY. I think that's a small mistake. My apology for that. That should be RTY and not TPY. So what is the TPY? The TPY is the percentage of the units that went out from a specific work center correctly without a modification or rework. Let's go to the formula and understand better what is the TPY. The number of goods passed right from the first time divided by the total number of goods. As an example, you have a work center. That work center is assembling certain parts together, and you ask the operator how many units input came to you as materials, raw materials to produce output. For example, he tell you, okay, I received materials for 100 box, and I did right from the first time 95 boxes. While there were 5 boxes, I found some problems in the parts, missing materials, which led that I had to make some kind of rework and modifications for those 5 parts. So that's why we mention here that 95 parts went out from that work center without any modification or rework. So the TPY in that work center is 95%. The gold throughput yield is the total TPY for different work centers. So if I have work center A, B, C, and I calculate the throughput yield for each center, then the goal, the throughput yield should be the multiplication of each TPY together. Then the sigma level is found to be calculated by the norm sine V for the 1 minus the defect per opportunity, which is considered to be also the TPY, plus the 1.5. So now I believe it's the time to go to the working example, and let's see. So in that example, it says that a factory specialized in producing refrigerators and cooling units has reported the last month a total productivity of 300 units. If we know that the opportunity of defects per unit was found to be 25 defects and the actual defects were found to be 243 defects, what will be the process sigma level? You can see here downside, I have put all the formula of the parameters. And let's go now to understand the solution steps for the sigma process. Okay, so I've summarized the example in the Excel sheet, and let's go to analyze more deep the exercise. So from that exercise, we can see that the total units produced we 300 units. So that's the total number of units produced, which is known to be N300. Then we have the opportunity of defects per unit is 25 defect, because here it's mentioned if we know that the opportunity of defects per unit is found to be 25 defects. Maybe someone might ask me, okay, how did you calculate the those opportunities of defect, or from where we can get it? Well, if we look here to that table, where I can make a little bit a little more focus on that table here. Okay, so you can see that this is a checklist, and that checklist, it contains all the defined possible defects that might happen. And this is mainly done through a brainstorming workshop where you gather the engineering team, the production, the QC, and they start to estimate all the kind of the defects that might happen during the execution of the project. So as you can see, for example, here, if we go to the example, they mentioned that they found a total of 243 defects. So, and from where they get this one, then you can get it from the punch list of the QC, or you assign a quality assurance supervisor who will start to monitor all those defects from the production line. So the guys in the production line, and of course that's a dummy example, he found that a summary of the all the punch list for the 300 units which had been tested by the QC, they have found that there were 45 paint scratches, the 5 defects of bent door, 18 gasket scratches, door misalignment for 12 products, door hinges problem 4 times, door handle 12 times, and so on. And if we calculate all the those values, the sum of all those values, we have found to be the 243 defects. So we have now the opportunity of defects per unit is 25, we have the number of units produced is 300, and we have the total number of defects which we have found, the 243. So let me erase again those numbers so we can see by ourselves how those values come from. So we mentioned that the OPU, the opportunity of defects per unit, is the 25. Then we have the number of units produced, we are 300. Sorry, and we have found that the number of the total number of the defects found, we 243. So as you can see, I've plotted all the formula for the calculation of the sigma level in that table. And here are all the formula that we need to calculate. So we have the DPU, and the DPU is calculated by dividing the total number of defects by the units produced, which was 0.81 defect per unit. Then we have the total opportunity of defects, which is the 25 multiplied with the 300, it's showing 7,500. Then we have the defects per opportunity, and this is calculated by two ways, either to divide the defect per unit divided by the opportunity of defect per unit. And so as we highlighted, the defect per opportunity is calculated by dividing the defect per unit, which is the 0.81 defect per unit, divided by the DPO, the defect per opportunity, which is the OPU. OPU, which is the 0.81 divided by the 25. So let's see what will be the result. Let's do it together so we make sure that we are doing the right calculation. So the DPU is 0.81. So here is the 0.81, which is the D9, divided by the OPU, which is the 25. So let's see, it's giving me 0.0324, which is the same result that we have here. And actually, it can be even calculated by dividing the total number of defects divided by the total number of opportunity. So the total number of defects, which we are the 243, divided by the 7,500, it should give you the same result at 0.03. Okay, so after that, we need to calculate the DPMO, which is in fact the DPO that we calculated, multiply with 1 million. So that's 0.03 multiplied with 1 million. It will give you the 32,400. And then we have the TPY, which is the throughput yield, the 1 minus the, either you can calculate it by minus the DPO directly. Here it's mentioned 1 minus the defects divided by the total opportunities of defect, which in fact, this is the same rule of the DPO. So the DPO here is 0.03. So if you you follow the formula 1 minus the 0.03, it will give you the 0.97. Okay, so the 0.97, we from that equation, from the formula, from the TPY, we can calculate the formula of the sigma level. And again, we can say that the sigma level, if we type the formula norm sine V, 1 minus the DPO, which is found to be 0.03. Okay, and I will close my bracket, plus 1.5. It will give me 3.35, which is my sigma score. Or I can say, instead of 1 minus the D11, I will take directly the TPY. Okay, so I will take the TPY, and then it's again giving me the same result, 3.35. So here we can understand that the sigma score for that factory is 3.35, which means that this factory is classified as an average industry, and the cost of the poor quality will be in between the 20 to the 30%. The cost of the quality, sorry, will be in between the 20 to the 30%. So what does it mean? Again, it depends upon the annual sales of that factory. Suppose they are producing the refrigerators with an annual sales of $10 million, like the first time we gave the example, then that means that the cost of the quality should be something in between the $2 to the $3 million. So friends, you can see from there that always there are plenty of opportunities of generating high savings by reducing the defects, and that's the main role of the Lean Six Sigma. Okay, so we understood how to calculate the sigma level, and that sigma level is actually related with the discrete data. As you can see here, it's called the discrete data, which means this is the sigma level that is calculated based on counting data, counting of the defects. There is another way to calculate the sigma level for the process manufacturing, which is mainly related with the continuous variable data, but this will be in another session. So I thank you for your good listening and watching. See you for the next session. Thanks.